guess the first thing to mention before I show you the parts is what it's trying to do.
Yes.
Because you know this already, but a lot of people don't realize that the problem with the climate is bigger than we previously thought, and that it's no longer enough just to cut emissions. We need to be taking carbon out of the air as well, ways of cooking onto cookstoves that make biochar. So let's start by firstly having a look at some of the charcoal, the biochar. Let's see. Can you see the stuff in there? This is the amount that was left over from one use of the cookstove. So this is probably about 20 minutes cooking. Gives you a handful of biochar like that. And that would be enough to mix in with something like a bucket full of compost. And then that would be enough to grow a tree. I'll show you the working part first. This is where the action happens in a biochar making cookstove. This is the furnace. So this holds your fuel. You put the wood in there at the beginning, and when you finish cooking, you're left with the charcoal in here at the end. There are some little flaps cut at the top and the bottom. And what that does is it allows two flows of air to come into the furnace, into the main part of the cookstove while the burning is happening. And the first flow of air is often called the primary air, because that's warm air that's coming in from outside. The warm air passes by the burning of inside the furnace, which warms it up, and then it goes in these little holes. But as you can see, the hole is very small. This is like a 2-millimeter gap, and there are 4 of these around the outside, so it's not a big flow of air. The flap at the top here, I can just about squeeze a little finger in here, so that's about a centimeter gap. That's a slightly bigger flow of air, and what you're trying to do with that is again create a preheated flow, so the air again passes by the burning hot part of the side of the furnace, and then it goes into the top. And what it's finding is in there is the byproduct of the process of making the charcoal, which is called wood gas. So as the wood is converting itself into charcoal, it's letting off a gas. And so some of the mass of the wood is turning to a gas, and it's no longer part of the carbon of the wood. So it's going to sit in a base of some kind, and you can use a saucepan or a metal tin. This is a biscuit tin. So the furnace is just sitting in there. And the biscuit tin serves a dual purpose, because when you finish with the cooking, you want to make sure that the biochar stays as charcoal. You don't want it to burn. And of course, when it's finished cooking, the biochar is hot. And so what we need to do is to stop it from cooking. And all you need from that is the lid of the biscuit tin. So the furnace comes out, and the lid goes onto the biscuit tin, and your hot charcoal is in there. The next piece to show you is what we've called the air control piece. And that's something just to give you those flows of air, because the air is going to come in from all directions if you've just got the base and the furnace. You want to get a bit of control over the air to make sure that the flows are about the amounts that you want coming in, and to make sure that the air is preheated when it goes into the furnace. So that's where we are using this piece here, which is the air control piece. And all that's doing is allowing the air to come in towards the furnace through these big flaps here, the 3 big flaps around the side. And this is just another big tin can with a handle attached. And in the top, rather than taking the ends off both ends, we've left one end on the top. The bottom has got the end taken out so that you can put it down over the furnace. And in the top, there is a hole cut. I think it's about 6 centimeters. That's where the flame comes out. So that goes down over the top of the furnace. And then you can see the furnace is in there in the middle of the air control piece, and the air control piece is sitting inside the base. I'll just take it out now, take it out of the base. So I'm just holding the furnace now in the air control piece. And you can see that there's a bit of a gap there. You're wanting, well, like 1 to 2 centimeters is ideal for this gap between the furnace and the air control piece. So you can see that the air that's come down the side of the base and into these, into the air flaps of the air control piece is now available to the furnace. So the air is running all around this gap here between the furnace and the air control piece. And that means that some of the air can go down and become the primary air that feeds the process of converting the wood into charcoal. And some of the air can go up, which will be probably the larger flow of air. But also because it's hot, it'll tend to go up. And it'll go through these larger holes in the furnace, the secondary air holes, and mix with the wood gas. There's a bit of a gap between the top of the furnace and the top of the air control piece. So you can see there's a bit of a mixing space. And you want at least 1 centimeter. It could be, between 1 and 5 centimeters is good for this space. So this is the chimney piece. It's sitting on top of the air control piece. And the air control piece is sitting on a kind of solid base. And this is quite solid as well as the chimney piece. So that gives you a sort of a stable platform. The chimney piece is actually made of 2 cans. There is an inner can, which is small, and an outer can, which is large. The flame coming out of the mixed wood gas and secondary air is coming up here. And this space, this sort of distance of 10 to 13 centimeters as it comes up the small can, that gives a chance to make sure that the wood gas is properly burnt. So if there's something in there, some volatile compound, some bits of hydrogen or methane or carbon monoxide that are still in there, you want to make sure that they're all burnt before they get to the top and before they get out into the air that you're breathing as you're cooking. And so that's what this chimney does. It also provides a bit of pressure, a bit of suction to the flow of the gases. You find that the flame will actually drive faster and more reliably once this little bit of chimney is put on top. So the flame is going up here to the top, and then you've got a gap of, you want at least 4 centimeters, say 4 to 7 centimeters would be fine. There's a gap between the top of this inner chimney and the top of the large can where your fry pan or your kettle or your saucepan are resting. And so that gives a bit of space for the flame to be working underneath whatever it is that you're cooking. So the flame will tend to spread out to this whole area. So you provide a path for the flame and the exhaust gases to come out with these 3 oval holes around the side of the large can, around the side of your chimney piece. And that just allows the gases, after they've completely burnt out, to then escape to the air. And they should be more or less safe to breathe at the concentrations that they'll be in when they're mixed with the air that's in the surroundings. There is a hole that's cut with the tin snips in the bottom of the large can. And when this was made, there were some little flaps. So it looks like just a plain hole now, but when it was made, there was another centimeter of metal on the inside of this hole, which has been bent up on the inside. Able to see where the little flaps are folded in. So the bits of metal that came from the large can are folded in around the edge of the small can. So there's a little ridge on the small can that gets clamped in place. And then it more or less should stay in place after that. That's pretty secure. And you just use a pair of pliers. There is one last little piece that I haven't shown you yet, which we're calling the fuel spacer. And this is just made from one of the ends of the large cans that was cut off. Because, we've used 3 large cans to make the cook stove. So there's a lot of leftover pieces. So this is just a little disc of metal. It's had the diameter slightly cut down so that it'll fit inside the furnace. What is it? There's maybe a 2 centimeter gap on the edges. So, anything between like half a centimeter or to 3 centimeters gap between this fuel spacer and the edge of the furnace would be fine. And it's a slight cone shape, which means that when it's sitting flat, all it's basically doing is excluding the fuel from a small area, from a little small cone-shaped area right at the bottom of the furnace. And that just happens to be the part of the furnace where it's most difficult for the primary air to reach. So you've got, if you look at the fuel spacer here in my hand and the furnace sitting over the top, the primary air can get in fairly easily to the parts of the fuel that are on towards the edge of the furnace. And the primary air can also reach the parts of the fuel that are further up inside the furnace. And then you'll know when it's totally transformed and when the cooking has finished with that cook stove, because the flame will go out. The flame will go out, or the flame will disappear back down inside the small can of the chimney. If instead at the end you get a bit of a smoke coming out when the flame dies down, then that probably is a sign that you need to use the fuel spacer to exclude the fuel from that little small cone-shaped area right at the bottom that's quite hard to get the primary air into. If you're getting odd bits of smoke all the way through your cooking, that probably is a slightly different clue. That tells you that your fuel might generally be a little bit too damp, or there might be a few damp pieces mixed in with your dry fuel. And we want to be starting the fire at the top. And what that does is it means that the flame will progress very evenly. You get a gradual progression of the flame from the top to the bottom. Whereas if you started from the base, then the flame would just zoom up through the fuel. It would just go straight up. And you wouldn't get this nice, consistent, regular flame over the cooking period. This is your tinder, and the tinder is then going to be used to start the cardboard burning. And then the cardboard provides the heat to start your wood fuel burning. But all you want to be doing is getting enough cardboard in there so that it will burn for about maybe up to 2 minutes, more than 1 minute at least. And that flame burning for that much time should allow the heat and the flame to be transferred through to the wood. Now let's see if it's worked. So as soon as you've got a flame that was covering the furnace, say at least a third or more, 2/3 is good, covering that much of the surface of the fuel, then you can put your air control piece on. You can put your chimney piece on straight away. You can see the flame has now died down. The flame has disappeared inside the cook stove. Just having a look. It's not even coming up the chimney now. So there's still a little flame in next to the charcoal, but it's no longer making more charcoal. It's actually just burning the charcoal that's already there. So this is a good time to stop the process. So I just use the handle to pick up the first 2 pieces and put them down somewhere where the heat, they're a bit hot. They're not massively hot. It's probably 100 to 200 degrees, but it'll still char something if it was a plastic or metal table. So you could use a couple of pieces of wood from your wood fuel. I've got a metal trowel there, a gardening trowel in my other hand. Let's see, you can see the charcoal. So that's glowing. There's a tiny flame, but it's basically not burning anymore. And of course, the base will be really hot, so you don't want to be touching the lid with your hand.